Hey, I'm Srinivasan Ramakrishnan here, and today I'm doing a chapter 1 review for my math class. And in all, five lessons in chapter. Okay, so for chapter one, I'm going to do 5 lessons. So today for lesson 1, we're learning about expressions and variables. Variables. A variable is a letter that represents a number. So, for example, here, n. So I'm putting n. So n is a variable, and has to represent a number. So n would represent 9, for example. So I would say n equals to 9. So that's my answer. N will equal 9. So this is like a variable. So right here, a variable. Numerical expression is consists of like numbers and operations. So it's a problem that consists of numbers and operations. So numerical expression would be 7. I'll say maybe actually no, here 1 plus 1, for example. This is a much easier way. 1 plus 1. That's a numerical expression. So 1 is the two ones are the numbers, and the operation I'm using right now is addition. So 1 plus 1 is obviously like 2. And so here's the numerical expression. And the variable expression consists of numbers and variables and operations. So it's kind of the same thing as a variable and numerical expression. It's the same as a numerical expression, but it's like also including the variable. So it would just be like this: 7 plus 8 minus n. So the variable is n, and the operations I'm using is addition and subtraction, and the numbers I'm using are 7 and 8. So n has to represent numbers. So n has to equal, for example, 1, and so 7 plus 8 minus 9. Oh, sorry, 1. Oops, 1. And 7 plus 8 will equal 15. 15 minus 1 will equal 14. So that's my answer, 14. So this is a variable expression. So next we will just wait. So next here, there are many ways you could write, like there's many ways you could write multiplication. So at expressions there's many ways you could do multiplication. So for example, there's 2y. That's the one way to write in multiplication for the variables. There's 2 and then put parentheses and put the y inside the parentheses. There's 2 dot y, which is 2 times y also. You could do parentheses 2 and parentheses y, so it'll also be 2 times y. Or you could do also like parentheses for 2 instead of y, and for y like that. It's the kind of opposite of the one that's like 2 parentheses y. So these are like many other ways you could use multiplication as expressions, as you can see here. So for division, there's also not many ways for expressions you could use. So if you did 6 for divided by n, it would be like you could use 6, the division symbol, and n. You could do 6, like a 6 fraction n, like the fraction way. You could put 6 on top as a numerator, and the n as a denominator, kind of like that. And you could probably also use like the slash, like 6 slash n, which is like division. So there's only like 3 ways you can mostly use it. So this is for division, 6 divided by n. And so yeah, that's one other way. But division, you can't do the opposite. You have to do the exact way to tell you to. So it's not like multiplication or addition. For addition and subtraction, just like the main way you can just do it is just like 1 plus n, and for subtraction, for addition, you could do that, 1 plus n. That's the main way. That's the only way I guess you could do it. And for subtraction, you could do mainly you could just do only this, like 10 minus n. So that's what you kind of do. There's like no other way to do it for subtraction and addition. Most of it are multiplying and dividing. So here, yeah. So that was lesson 1-1, and that's for expressions and variables. So I hope you enjoyed the video, and yep, see ya. I'm Srinivasan Ramakrishnan here, and that's my lesson 1-1 review. Thank you, and make sure. Lesson 2 today, we're learning about powers and exponents. And so for powers and exponents, so the power is like a power is like a repeated multiplication problem, kind of. It's like kind of like that. Like how multiplication is a repeated addition problem. Power is like a repeated multiplication problem. So that is kind of like the same as kind of like multiplication. So yeah. In the power, there's like the base and exponent. So the exponent, so the base actually is a really huge number in the power. So example, if I have the base, so I have an example, like, so if you have base, the base would be probably like 6, for example. That's a number using to multiply the number of times you're using to multiply it. So that's what I think of the base. And for exponents, it is the number of times you're multiplying that number. So yeah, that is like the number of times you're multiplying the base number. So example, now I'm doing an example, like a real example. So yeah, I'll have 6 cubed. So instead of saying third power, you say cube. 6 to third power is like 6 cubed. So like 6 squared is 6 to the second power, and 6 cubed is 6 to the third power. So that's another way to say 6 to the third power and 6 to the second power. It's like the second power and third power, yeah. So my example is I'm doing 6 cubed. So 6 would be the base, and 3 would be exponent. So, but in all, this whole thing right here is a power. People think it's called exponents, but it's really called a power. So yeah, and so 6 to the third power, you change it into the multiplication form, which would be 6 times 6 times 6. So the exponent is the amount of times you use to multiply the number 6, and the base is the number using to multiply the number of times you're multiplying the number of times you're multiplying the exponent. And so 6 times 6 is 36, and 36 times 6 is just a second. Let me just do the problem here. Is 216. It's 216. So 216 is the answer. So the circle answer at the bottom, not the 6 cubed. 216 is my answer. So it's right here. So here, I'll show you. It's right here. It's right. So 216. So 216 is my answer for that. So that's what kind of powers are. And so yeah, that's my lesson today. And so that's my lesson today. That's lesson 2, which is powers and exponents. And I hope you enjoyed
Third lesson. The third lesson today my third lesson today is order of operations. So for order of operations, the meaning for me I would think of is PEMDAS.
For PEMDAS, PEMDAS means actually for P is parentheses, really bad spelling though. Parentheses for P. E is for exponents.
M is for multiplication. Sorry for that. And D is for division. A is for addition. The S is for subtraction. Okay, so that's PEMDAS. P for parentheses, E for exponents, M for multiplication, D for division, A for addition, S for subtraction. So, easy way for me to remember PEMDAS also is to say, for P, please, E for excuse, M for my, and D for dear, and A for aunt, and S for Sally. So it says, please excuse my dear Aunt Sally. So that's PEMDAS. That's how I remember it. And here I'll give you an example of how to use a PEMDAS in the problem. Or like or I'll do order operations like for this. So I'll do a problem. So it'll be 4 plus 3 in parentheses, and after it is divided by 14, I'll put, and 3 to the square to the second power times 3 minus 2. And so since 4 plus 3 is on first thing to come on left side for parentheses, since there's 2 right here, just like 1 and 2 right here, I choose the 4 plus 3 because that's the first thing comes on the left side. So whatever like say you have 2 exponents, and whichever is first on the left side, you do that one first, not the one that you choose you want to do. So I first do 4 plus 3, which is 7, divided by 14, and do 3 squared times 3 in parentheses. I redo the problem. So now, since there's a parentheses again, there's 2 things I do parentheses first. So there's 2 things I could do in the parentheses. I could do the exponent or the multiplication. So I'm doing exponents first because after the parentheses in PEMDAS, it's exponents for the E. So I'm doing exponents. 3 times 3. So 3 squared is 3 times 3, and 3 times 3 equals 9. So 9 times 3 in parentheses minus 2 here, 7 divided by 14. Sorry, just a second. 9 times 3, I do it again, parentheses, which is 27, and the 7 divided by 14. I put parentheses over here. Okay, and do minus 2. And next I do, so now it's actually like 7 divided by 14 times 27 minus 2. Because actually right here, like in lesson 1 that we learned, you can write multiplication in different ways for expressions. So this is 14 times 27. So I mean, like first there's after exponents, there's multiplication and division. So first is division. The first thing on the left side is division. So I do division first instead of multiplication first. So 7 divided by 14 is 2 times 27 minus 2. Sorry. Then you do 2 times 27. So I'll do 2 times 27 right here. 27 times 2. 14, 5, 6, 64, 64, minus 2. So 64 minus 2, that's the only problem we have left, so that's obvious that I do 64 minus 2. So 64 minus 2 is, put 2 here, and 4 here, so it's 42. My circled answer, right here, is 42. So that's my answer, guys. So that was my answer, guys. So the answer is for lesson 4 video, and today we are comparing and ordering integers. Hey, so since we're comparing and ordering integers, so for integers, an integer is actually like it's like the numbers. It's the whole number that is after and before 0. So in the integers, the numbers that are like before 0 that have like the minus sign, the whole numbers that are before 0 that have the minus sign is a negative number. The positive numbers are the ones that are the whole numbers that are after 0, and that have the positive sign, or just like regular whole numbers, which are positive which are positive integers. So, and the 0 is a neutral number because it's not like positive or negative. It's actually just like another part, like another like number, like another. It's like just like in the middle. It's not like positive or negative. It's a neutral. It's not either one of them. So, yeah. So those are like what are on the number line for integers. So for example, if you are comparing -70, for negative side, if you're comparing -70, -54, -35, -19, -9, if you put a number line, for example, you would if you put a number line, you would usually think like the larger number is like in the positive side. You would usually think you always think the whole number. The larger number is, the greater it is, and the lower number is, the least it is. But like in a negative world, the larger number is least, the lower it is, and the lower the number is, the greater it is. So it's like the opposite of the positive side. So that's how it kind of is for negative side. So if you're comparing -70, -54, -35, and -19 and -9, the first thing. So if you're doing from least to greatest, the first least number that'll come first is -70, then -54, then -35, then -19, then -9. So -9 is the highest number in that comparing, or like then that number line, and -70 is the lowest. So it's very different from positive. So you can see that, and yeah. So that's how you kind of compare. And okay, so let's now use positive and negative numbers, right? For example, okay. So we have -4, 0, 2, 5, 6, and -8. So how would you compare that? So first, I mean, you always start from negative side because that's always lower than the positive, actually. So you would have -8, -4. So that's all in the negative side. Then 0 is neutral, so it's always like after. It's always told like that. The neutral number is actually after. It's actually after a negative number, but it's before the positive, so it's in the middle. So zero is a neutral number, and then after there's positive numbers. There's positive numbers right now. So you have 2. So it's 2, then 5, then 6. So that's how you order the integers from positive to negative and everything. So now. There's something called absolute value, and absolute value is like the distance from a number. So like, for absolute value, like pretend we're comparing like the absolute value of 6. First, if you're putting absolute value, the sign that you put is like the very straight line down like that, and like the number should be in between that. So that's like the absolute value sign. So that's how sign is for absolute value. So the absolute value is let's think here. So distance from it is a distance from a number. So use 6 for example. The absolute value of 6 is 6 because how many numbers is away from 0? So it's a distance from away from 0. So it's 6. But if you use a negative number, it's for -6 for example. It's still 6 because there's no way you can it's like you can't really use a negative for absolute value though, because like if you're like saying -6, like the distance it is away from 0. There's no way to do negative numbers. So yeah, so that's how I do absolute value for negative and positives. But so for opposites, they may seem the same for absolute value, but it's actually different. The opposite are the two numbers having the same like it's like the opposites are like the things that have the same absolute value, but like that like have different signs. Like I mean, like it's like the opposite. Pretend 6. Example for 6. Like 6 is the opposite of 6 is -6 because like the opposite of the absolute value. So it's really hard to say, but the example is kind of like easier to tell. So the opposite of 6 is -6. The opposite of -6 is 6. So it's the opposite of the two signs, the two like negatives and positives. So it's the opposites of those. That's what opposites are. So for example, yeah. So like I'll just give one more example for the opposite of -5. Like okay, then the opposite of 0 is 0 because there's no way you could do the opposite of that. Same for absolute value. If you're doing the opposite value of 0, it's still 0. So the 0 is no answer for it because it's a neutral number. So that's for the absolute value and opposite, they're still the same. But like the opposite of pretend like -10 is 10. The opposite of 10 is -10. So see, so that's like a really easy way. That's a really easy way to just like think of opposites and everything. And still, opposite and absolute values. Remember this. It's different from each other because absolute value is no negative. There's no negative number, but in opposites you can use negative numbers. So it's a much easier way to remember.
This lesson today is adding integers, not subtracting, not dividing, not multiplying, but adding integers. So, for adding integers, actually like it's pretty simple. Like than like subtracting. For me, it's like it's more simpler for me than adding or multiplying and dividing integers to me. And like for adding integers, I'll show you how to do it. So.
Yeah, so there's many ways to add integers. So one way, which I like to do most actually, which is the most easiest for me, is actually doing this, using the additive inverse. So it's like you're using the opposite of your actual number. So I'll show you. Like when you're adding, pretend you're doing -9 plus 3. Okay. Before that, actually, before you use anything for additive inverse, you first have to notice you use negative, or like whenever see there's -1, there's a negative number, and there's a positive number. So you have no. Should I use a positive? My answer is supposed to be positive or a negative number. So if you can see here, there's a 3 and a 9. So actually, before like you change it. So let's just use the absolute value. See which is bigger, the 9 or 3. So change the absolute. I put the absolute value of -9, which is 9. The absolute value of 3 equals 3. So which is bigger, 9 or 3? The answer should be 9. So 9 is the larger number. So 9. So you know the answer is gonna be negative. It's gonna be a negative answer because the 9 is bigger than the 3. So the answer is gonna be negative. So you know it's gonna be negative though. So so you change. So now you just do 9 minus 3. So 9 minus 3. So yeah, sorry. 9 minus 3 is 6. So the answer would be 6. And that's how I get the answer of -6 for my answer, because you use your absolute value and see which is bigger. So it can get so see if it's negative or the positive that gets the larger one. So I like look, see when you change, so when you're doing adding integers, you change it to absolute value, so you can see which is a larger number, and whichever number it is, you can use that sign that it has as the sign that you use for the answer, because you know that's gonna be answer because you use additive inverse, so you subtract instead of adding. So that's how you get your answer. But if you have like same positives, or maybe like same negatives. Sorry, wait, negative right here. So 3 plus 3 is 6. You sure? I mean, this is an obvious one because this is positive, and I guess you should like maybe learn this in first grade or like second grade. I don't know. I'm not sure. But like this one's the obvious one. But like, see, you have two negatives, right? So you know the answer is gonna be negative because there's no positive. There's no like answer or positive. So it's just only gonna be negative. So 3 plus 3 is 6.
so it's obvious. So it's like these two are just like whichever. If they have the same sign, you just add regularly. But if they have different signs, you subtract. So that's how I remember, and that's how I add integers. Hey guys, so in my chapter 1 review, we had 5 lessons in all. So yeah, so today we learned about variables and expressions. We learned about powers and exponents. We learned about order operations. We learned about comparing and ordering integers. So that's 4. And the last one, we learned how to add and subtract integers. So that's 5 lessons in all. And yep, I hope you enjoyed my video. And make sure to leave a like in the comment. So bye. This is Srinivasan Ramakrishnan here, and I hope you enjoyed the video. And especially for Ms.Jasper, I hope you enjoyed the video too. And this is my chapter 1 review. And see ya. Bye. And bye, Ms.Jasper.